This technology can turn any surface into a power plant. MIT engineers have made a groundbreaking advancement in the field of solar technology. They've developed an ultralight fabric solar cell that can transform virtually any surface into a power source. Calling these solar cells innovative would be an understatement. They're revolutionary. Much thinner than a human hair, yet they're robust and efficient. These cells are a mere 1/100th the weight of conventional solar panels. Yet they generate 18 times more power per kilogram, all thanks to semiconducting inks and scalable printing processes. Glued to a strong, lightweight fabric, these cells are easy to install on any fixed surface. This creates endless possibilities, from wearable power fabrics to rapid deployment in remote locations during emergencies. Think of integrating them onto boat sails for power at sea, or sticking them onto tents used in disaster recovery operations. They could even be applied to drone wings, extending their flight range. This technology is not just about generating power. It's about integrating power generation seamlessly into our daily lives.
Solar for the past several years has been the cheapest form of energy, forgetting renewable or dirty, just the cheapest overall, down to a few cents per kilowatt hour. So that means that in one view of the future, we build more and more solar on the rooftops of homes, businesses, large solar arrays in the deserts, and we power our whole economy, or nearly our whole economy, with solar and other renewables.
Traditional silicon solar cells have their limitations. They're fragile and need to be encased in heavy glass and metal frames. This restricts where they can be installed. But MIT's new solar cells are a game changer. 6 years ago, the team at MIT's One Lab created solar cells so lightweight they could sit atop a soap bubble. However, those cells were made using complex processes that were expensive and hard to scale. The new generation of solar cells is entirely printable. They're made using nanomaterials in the form of electronic inks. The team uses a slot die coater to deposit layers of these materials onto a substrate that's only 3 microns thick. Then, using screen printing, an electrode is added to complete the solar module. The result? A solar module that's about 15 microns thick, which can be easily peeled off its plastic substrate. But there's a challenge. These ultra-thin solar modules are delicate. They can tear easily, making them hard to deploy. The solution? Fabrics. The MIT team identified fabrics as the perfect substrate for these cells. They found Dyneema, a composite fabric weighing only 13 grams per square meter. This fabric is incredibly strong. In fact, its fibers were used as ropes to lift a sunken cruise ship from the Mediterranean Sea. So, how do they fare against the competition? When tested, they could generate 730 watts of power per kilogram when freestanding. When deployed on Dyneema fabric, they generated about 370 watts per kilogram. That's 18 times more power per kilogram than traditional solar cells. Moreover, these ultra-thin solar panels could potentially decrease the amount of solar waste that is inherent to traditional solar panels. When their life cycle is over, old silicon panels have nothing to do other than filling landfills, adding to the ecological footprint problem that we are facing today.
We are expecting to see kind of 2 waves of panel waste coming. So the first wave should be about 2030. And then there's a huge wave that's expected to hit about 2050. And so I do know with that wave in 2050, the global estimate of PV waste is 78 million tons of panel waste.
Durability is another strong suit of these cells. Tests showed that even after rolling and unrolling a fabric solar panel over 500 times, the cells retained more than 90% of their initial power generation capabilities. The future of solar technology looks bright, thanks to innovations like these.